Hello students, today we'll start with another chapter of chemistry, the name of which is alcohols, phenols and ethers. Now to begin with, all these three compounds, alcohols is basically functional group OH, phenol, it also contains OH with a benzene ring attached to it, and ethers, it also contains O. On both the side you have two alkyl groups attached. Now these alcohols, phenols and ethers have wide application in industry as well as in our daily life. For example, the wood polish what we use for polishing furniture, it contains nothing but ethanol. The flavors of tobacco and certain foods are due to menthol. Now a substance present in the vision of our eyes is nothing but retinol, which is made up of alcohol. So herein we'll begin with the first unit, that is alcohols. Now the certain points which are always included in organic chemistry are, which you got to note it down, is first we start with the definition in that particular chapter. Second goes is the classification of those particular compounds. Third is the nomenclature. Fourth is the preparation of those particular compounds. Fifth includes the properties. Properties like, first, chemical properties, which includes all the reactions, and physical properties, which tells you about the state of the substance, its melting point, boiling point, gravity, and many other variable factors. And lastly is the uses. So all the chapters in organic chemistry we are going to study under this 6 particular points. Now today we'll begin with the first unit, that is alcohols. Now alcohols, the functional group for alcohol is it consists of hydrogen and oxygen, right? Collectively it has been called as hydroxyl group. Now the definition. As such, it is obtained from alkenes. Now alkenes, these are generally represented as R, H. Now in this, you remove hydrogen from alkene and add a OH. The corresponding compound what we get is R OH. The name is derived from the parent itself. the word E from alkene is removed, and in place of that we add the word OL. So the IUPAC name for alcohol is alkanol. Now the definition, if we go to see how it is, alkanes may be defined as derivative it may be defined as the derivative, but what derivative? Hydroxyl derivative, hydroxy derivative of alkane. So alcohols, these are defined as the hydroxy derivative of alkane. For instance, I'll give you certain examples over here. This is an alkene. The first member of the family of alkene, methane. Now in methane, you remove one hydrogen, and in place of that you add a OH. So this, the compound what we obtain is like this, CH3OH. Now the name goes in such a manner, the word E is removed from here, and the word OL is added in that place. Right now E is removed, we get methane, methan, remove the word E, add OL, methanol. Similarly, if we take another compound, the next family, this is 2 carbon atom alkene, ethane. Same, minus H, add OH. So this H you remove from here, and in place of that H we add a OH here. So the word E minus E, add OL over there, ethane, E is removed, you add OL, ethanol. Is it clear? Next, we'll go for the classification. Classification. Now, alcohols are classified based on the number of OH groups attached to the carbon atoms. Right? It depends upon the number. First is called as monohydric alcohols. Monohydric alcohols, it contains only one OH group. Only one OH group attached to the carbon atom. For instance, like this, OH. Only one OH group attached to the carbon chain. This, the common name, Two carbon atoms derived from ethane is called as ethyl, and OH is called as alcohol. We'll see the IUPAC name. Two carbon atom name is ethane. The word E is removed. We add OL over there. Ethanol. Same, we'll go for three carbon atoms. CH3, CH2, CH2, OH. Three carbon atom alkane is propane. Accordingly, its alkyl will be propyl. Now the three carbon atoms are in straight chain. It is called as N-propyl. And the OH is called as alcohol. Now in the IUPAC name, as we have done in 11th standard, we'll follow the rule. We'll start naming from the functional group. This will be first carbon atom, this is the second, and this is the third. Right? So 3 is propane, say propan, 1 on. So this was the first classification based on the number of OH group, right? Monohydric, mono itself means one, hydric means the OH. Now the second is dihydric alcohol. Dihydric alcohols. Di, the word itself implies it consists of two OH groups attached to the different carbon atoms. Attached to different carbon atoms in the same carbon chain. For instance, two OH. This is filled with H, 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 CH2, CH2. Commonly it is termed as ethylene. Two OH groups, they are called as glycol. So the IUPAC name, either this will be termed as 1, 2 or 1, 2. So it's ethane dash 1, 2 dash diol. Another example with three carbon atoms. OH, OH. This will be H2, CH, CH2. Three carbon atoms has been termed as propylene. 2H are called as glycol. Now the IUPAC name for this goes out to be 1, 2, 3. Three carbon atom means propane dash 1. The first OH group is attached on the first carbon atom and the second is attached on the third. 1, 3 diol. Next is trihydric alcohol. Now this contains three OH groups situated at different carbon atoms. Here OH, 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 CH2, CH, fill in the valencies, three OH groups. This propane dash 1, 2, 3 dash triol. The common name for this has been also termed as glycerine or glycerol. The next classification is where it contains more than 3 OH groups. Polyhydric alcohols, which contains more than 3 OH groups. Three OH groups situated on different carbon atoms. For example, we'll take a big carbon chain of 6 carbon atoms. You have the OH attached over here. OH, 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 OH. Fill in the remaining valences with hydrogen. CH2, H, 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 CH2. 6 carbon atom, hexahydric alcohol. The other common name for this is sorbitol. Now, further, the monohydric alcohols, they are also classified based on the type of the carbon atom undergoing hybridization to which the hydroxyl group is attached. Next is classification of monohydric alcohols. Monohydric alcohols, according to the type of hybridization of carbon atom to which hydroxyl group is attached. First is alcohols containing CsP3 OH bond. Now in this, the OH group is attached to sp3 carbon atom of alkyl group. OH group is attached to sp3 hybridized carbon atom. For example, this carbon, the valencies, here's the OH, right? Here you have the 2 hydrogen atoms attached and 1 alkyl group. So this carbon atom is termed as primary carbon atom, which is in the form of CH2OH. Generally, it is represented as ROH. And the general formula CnH2n plus 1 OH or CnH2n plus 2 O. Now, the examples for this, will replace the R with the alkyl groups ethyl alcohol or ethanol. Two carbon atoms, ethyl alcohol or ethane. The word E is removed, you add OL, ethanol. Next, we'll take another example of primary alcohol. Three carbon atom in a straight chain. Straight chain means N. Three carbon atom means propyl alcohol. IUPAC name 1, 2, 3. Propane. OH group is attached on the first carbon atom. 1 all. Propan 1 all. So the primary alcohol but in which the OH group is attached to the primary carbon atom. And the primary carbon atom is what? Which is attached to one functional group, two hydrogen atoms and one alkyl group. Next is the secondary carbon atom. OH attached to secondary carbon atom. OH. Now for this carbon atom to be secondary, it must contain one H and two alkyl groups. The alkyl groups may be same or it may be different. So in general, the functional group, it includes CH, OH. This is the secondary carbon atom. We'll replace the valencies, remaining valencies or the alkyl group, the R with different alkyl groups. One, two, three, or 1, 2, 3. 3 means propyl. Now the OH is branch in the middle carbon atom, so we'll use the word here iso. Isopropyl alcohol. Now the IUPAC name 1, 2, 3 or 1, 2, 3. 3 means propane, that is propan. The OH is attached on the second carbon atom, propan 2 all. You can increase the carbon chain further also. Now here the numbering changes, right? You have to number according to IUPAC rule. The OH over here must get the lowest number. If you start from here 1, 2, 3, 4, it gets the third number. If you start from here 1, 2, 3 and 4, from down you get the second number. So down way is the right way of naming the carbon chain, numbering the carbon chain. So 4 carbon atom is butane. OH is attached on the second carbon atom, butane 2 all. This is the IUPAC name. Now the common name 4 carbon atom is termed as butyl. Now the OH is branch, right? Branch means, but branch in such a manner, the carbon atom to which it is attached, the same carbon atom is attached to two different carbon atom. Now this carbon is nothing but secondary. So in short we call it as sec. Sec butyl alcohol. This was the secondary classification. Now the third one, is tertiary. You have the OH group attached to the carbon, the three valencies. All the three valencies are attached to three alkyl groups, maybe same or maybe different. So in short, the functional group over here is COH. We'll replace all the R with the alkyl groups. One carbon attached to three carbon is called as the tertiary carbon. It's called tertiary carbon atom. So the name of this goes up to be tert butyl alcohol. Now the IUPAC name: 1, 2, 3, or 1, 2, 3. Anyway, 1, 2, 3, 1, 2, 3. If you count from all the three directions, the second carbon atom goes onto the OH. So 3 means propane, right? On second you have the OH, propan, 2 all. This falls out to be the substituent methyl, which is attached to second carbon atom. So it is 2 methyl propan 2 all. The P over here, parent P, it goes out to be small. 2 methyl propan 2 all. Now the next classification is based on the type of hybridized carbon atom. Been called as allylic alcohols. In allylic alcohols, the OH group is attached to the sp3 hybridized carbon atom